for the chime. There it is. Okay, you guys. So here we are. All right. So this is a future test question. They're going to ask you to construct a function of this form. And notice the good thing is these match. That's very helpful. And this is a constant. That is very helpful for us. Okay. They want us to have this function's derivative be this. Okay. And it has to hit this anchor. And so as we learned earlier, this is A, and this is going to be our constant C. Okay. So the only really missing piece here is right there, f of t dt. And so the first step here, step one, is to rewrite the given derivative as a function of a dummy variable t instead of x. And so what I'm going to do is take my derivative, g prime of x is equal to e to the negative x squared. And I'm just going to rewrite it in terms of a different variable. I could use any variable I want. T is usually what they use. They require it here on this question, so I have to use it. So there it is. So that is going to be my integrand. Okay, that is going to go into here. All right. A and C are right there. They basically gave them to you. So we're going to say g of x is equal to, and I'm basically just copying this down, the integral from 4 to x. Notice that these match. Notice that's a constant. My integrand is e to the negative t squared times dt, and then plus my constant of 3. And there I have it. Okay. So not difficult. Okay. It just requires a little bit of precision. Okay. So let's see about this. Does this even work? Okay. Well, is the derivative really e to the negative x squared? Well, if this is a constant and this matches, then this right here, you just replace the t with an x, you'd get e to the minus x squared, which is exactly what it wanted. And then let me check it. Does g of 4 really equal 3? Let's try it. Okay, let's put a 4 in there. G of 4 would be the integral from 4 to 4, and you already see that happening, e to the negative t squared dt plus 3. Well, this piece here, because the upper and lower bounds are identical, would be 0 plus 3, otherwise known as 3. Sure enough, g of 4 is 3. Boom, it checked. I know I did it right. Okay, so that's special situation 1. Okay, all right. The next special situation is here. Okay, how are we going to handle this one? Okay, a special situation where they give us a function in terms of another function, and they ask for its derivative. Okay, and normally you'd think, well, gosh, if you integrate a function and then take the derivative, you'd end up back where you started, which is exactly right. The only problem is that these don't match, and that creates an issue for us. Okay, so we can't just say, oh, it just equals this, the square root of the sine of x. You can't do that. Okay, so what are we going to do? So here's a procedure you can use, and eventually get to the point where you don't need this procedure anymore. You'll know what to do in this situation, but here's what to do step by step. Identify the integrand. That's the part underneath the integral, or from the integral to where it says dt. That's the integrand right there. So we have the square root of the sine of t, and instead we're going to write it as a function of x. Okay, so we're going to rewrite that as So I'm checking my old notes from years past just to make sure I have it. Okay, so I'm going to call this g prime of t. I'm sorry. Let's do that. G prime of t is equal to the square root of the sine of t, like so. Okay. Whoops, I'm sorry. It says to write it as a function of x instead. My bad. Let me start over. Let me rewrite it as a function of x. I want to have a function there. I'm going to say f of x is equal to the square root of the sine of x. Okay. My apologies here. Okay. All righty. F of x is equal to the square root of the sine of x. Rewrite the integrand as a function of x. There we go. Okay. All right. The next step. Okay, apply this formula, the part 2 of the Fundamental Theorem of Calculus. It basically says, let's define capital F of x so that its derivative is f of x. And so very important to remember this. This is what we mean when we use capital F of x. This is an absolutely critical foundation of calculus, okay? It's just notation. So what this says is the integral from pi to x cubed f of t dt must be equal to this capital F evaluated here of x cubed minus capital F of pi, the lower bound like so. Okay, and so this is what we are calling g. This is our original function g of x. So what we're saying is g of x is equal to capital F of x cubed minus capital F of pi, like so. Okay, and there we have it. Okay, all right, now it's just a matter of applying out calculus and algebra to it. Okay, take the derivative of both sides. Remember that the derivative of a constant is 0. Also apply the chain rule if necessary. Okay, so check it out. By definition, g prime of x must be equal to the derivative of this. So chain rule, you do the derivative of the mama, don't mess with the baby, and then you multiply that by the derivative of the baby, 3x squared. Okay, and that's the chain rule. And then this is a constant. Even though we don't know this complicated function f, whatever it would look like, we're evaluating it at a constant. And so that's just a constant. And the derivative of a constant is 0. So I'm just going to rewrite this. G prime of x is equal to 3x squared times f prime of x cubed, capital F prime of x cubed. Okay. And then we're simply going to use this here. Capital F prime of x is just equal to f of x. And that's critical that we do that. Okay. So this business here, capital F prime of x cubed, is exactly the same thing as f of, remember, you replace this with that, x cubed. So let's go back and evaluate what that is. Well, we had that up here, right? F of x was the square root of sine of x. And so we simply replace x with x cubed. So we get f of x cubed is equal to the square root of the sine of x cubed. Okay, I want to be careful where I put that cubed. That would mean if f of x is the sine of x, then f of x cubed would be the sine of x cubed. Okay, and so we end up with g prime of x is equal to 3x squared times, and we just need this f of x cubed, which is equal to the square root of the sine of x cubed, like so. Okay, so this expression here, you could replace it with this, which is equivalent to this, 3x squared times the square root of the sine of x cubed, like so. And there I have it. Okay, there it is. I'm trying to find it on my old notes from before when I did this problem. And there it is, 3x squared times the square root of, yep, there it is. So this is g prime of x, okay? And so what I want you to notice here in this problem is that when we did, in the past, when we integrated something and then took the derivative of it, we just ended up back here. It would be the square root of the sine of x. But notice that didn't happen here. We didn't just get the square root of the sine of x. We have the square root of the sine of x cubed multiplied by the derivative of it. Okay, and so it's not quite as simple as you'd see. And how do you know that's going to happen? When these don't match. Okay, when these don't match, that's when you run into this chain rule issue. Okay, all right, so let's try this one. Let's do this guy. Okay, so the first step, it says here in the directions, notice that the dummy variable, I've switched to r now, which I'm allowed to do. X represents my upper and lower bounds, or a function of those is the upper and lower bounds, and I'm using r as the dummy variable. So you might see this on a test. Okay, what is the derivative of this function? Okay, so step one, identify the integrand and write it as a function of x. And so we're simply going to say f of x is equal to this integrand. We're going to write it as a function of x. So the square root of 1 plus x all over x. So that's step one. Okay, step two, apply this rule here. F of b minus f of a, what we call y, is equal to this. So we're simply going to say y is equal to g of x, which is equal to, okay, this capital f of x, I'm sorry, x squared, the upper bound, these do not match, okay, don't match, okay, minus this capital F of x. And notice this is not a constant this time, okay? So there it is. And so now we need to evaluate g prime of x. Well, g prime of x is equal to, well, by definition, the derivative of capital F of x. You do the derivative of the mama, don't touch the baby, and then you multiply by the derivative of the baby, 2x. Okay, in this case, f of x is not a constant, it's a function. And so we don't get to zero it out. We have to say minus f prime of x, okay? And then the next step is we're going to substitute this is always true, okay? F prime of x is equal to f of x, always, okay? And so what that means is g prime of x is equal to, well, if capital F prime of x equals f of x, then that must be f of x squared times 2x minus f of x. Okay, well, now we just need to figure out, well, what's f of x? Well, f of x, fortunately, we wrote it down right there. So f of x is this. Well, what is f of x squared? Well, if f of x is equal to the square root of 1 plus x over x, then f of x squared must be, you just replace every x with an x squared. It would be 1 plus x squared over x squared. And so I just rewrite my derivative g prime of x is equal to f of x squared. I just evaluated there. It would be the square root of 1 plus x squared over x squared times 2x minus lowercase f of x, that's here. So minus the square root of 1 plus x over x, like so. All righty. And then last step, you guys, we have an x squared in the denominator and an x here. One of those would cancel. I'm going to put the 2 in front. And so I have g prime of x is equal to 2 times the square root of 1 plus x squared over x minus square root of 1 plus x all over x. All right, and I could go on. The denominators are both the same, so I could say g prime of x is equal to 2 times the square root of 1 plus x squared minus the square root of 1 plus x all over x, like so. And there's my answer. Okay, there it is. All right, so pretty tricky. Doesn't exactly look like the original integrand, okay? It's not that simple. Normally, when you integrate something and then take the derivative, you make a round trip, you end up where you started. But the problem is this one doesn't match, and that one is not a constant either. And so we end up with a much more complicated situation there, okay? So there I have it. I've got my derivative, okay? All right, you guys, I think that's it, right? Yep, moving on to the homework, okay? So take care, you guys. Have a good one. Stay out of trouble, okay? Bye-bye.